Hello, my name is Chris Isaacson, and I'm here to talk about how water contamination can be caused by thermally degraded plastic drinking water pipes. So water infrastructure damage can occur due to fires, and this can be a structure fire or a wildfire. And this damage can come in the form of physical damage to plastic assets like tanks, hydrants, meter boxes, etc. We have a couple examples of that to the left there, with the top left picture being a melted meter box, and then a couple examples of damaged pipes. And this sort of physical damage can lead to leaks and breaks within the water distribution system. Additionally, there can be chemical contamination, specifically volatile organic compounds and semi-volatile organic compounds. And this sort of contamination has been detected in several water distribution systems across the American West following wildfire events. The sources of this contamination is currently unclear, and this acts as the driving force behind this study to understand if thermally damaged plastics may be one such source of that contamination. And to contextualize why this work is important, we looked at a few of the recent fires since 2017 and the number of water distribution systems that were impacted by said fire. And this is important as with the shifting climate, we expect there to be an increase in both the intensity and the frequency of these wildfire events. So understanding the source of this contamination is important to help inform water utility managers on how to respond to such disasters like wildfires. So as mentioned, VOCs and SVOCs have been found in water distribution systems following wildfires. So we have a table here with just a select few VOCs that were detected following the Camp and Tubbs fire. It's important to note this is by no means an exhaustive list. If you'd like to know more about the extent of contamination following these two fires, please follow the link provided on this page to a study put out by a research group in 2020. Now looking back at this table, specifically benzene, and this is important to focus on because benzene is a well-established carcinogen. The concentrations, the maximum concentrations following the Camp and Tubbs fire were 2,200 parts per billion and 40,000 parts per billion, respectively. To contextualize just how large of numbers these are, the US EPA considers something to be hazardous waste if it has over 500 parts per billion of benzene. So there was essentially hazardous waste levels of benzene flowing through the water distribution system. And outside of just the VOCs, there are SVOCs, which tend to be less focused on following these sort of disaster events in terms of what gets tested for in the water. However, Santa Rosa, following the Tubbs fire, did elect to test for SVOCs and did find a select few polyaromatic hydrocarbons, phthalates, and furans, just to name a few of the chemical compound classes that were detected. This is noteworthy because some of these compounds within these compound classes do have similar carcinogenic and toxicity risks that are also associated with the volatile organic compounds. And this last point is very important, that some of these SVOCs were detected in the absence of benzene. That means that just because there's no VOCs that get tested for doesn't necessarily mean you can claim a water is safe to drink, because there could potentially be SVOCs present. So potential sources of this contamination, one can be forced biomass structure combustion. So it's well established when you burn biomass, you do produce these VOCs and SVOCs into the air. And if you have a damaged water distribution system that has been depressurized, that air could be sucked into the water distribution system and spread throughout that way. A second potential source is plastic thermal degradation. So as mentioned, there can be plastic components spread throughout a water distribution system. This can come in the form of, say, a water meter or various premise plumbing. And when these plastics are exposed to heat, they will thermally degrade and form all sorts of compounds within the plastics that can then diffuse out of the plastic into water over time. And lastly, there's contaminated water back siphonage. So if there is contaminated water in a building, that can be back siphoned into the water distribution system. It is worth noting, however, that backflow prevention devices are being used more frequently, especially in these wildfire-prone regions. So what did our study find? We found that VOCs and SVOCs can be generated during thermal exposure of plastic pipes and air. So what we did was we took 11 different commercially available plastic pipes and degraded them at various temperatures. Now, all 11 of these plastic pipes were different sorts of materials, so a variety of different PEX materials, HDPE, polypropylene, PVC, and CPVC sort of cover the gamut of what we looked at. We took each of the sections of these pipes and degraded them in a muffle furnace for 30 minutes at various temperatures between 200 and 400 degrees Celsius. We did this because we wanted to get a varying level of degradation, as we would expect there to be differing levels of degradation during a fire event, depending on, say, if a pipe was buried or behind a specific wall versus an exposed pipe or what have you. And after degradation, we submerged these pipes in either water or N-hexane and measured what leached off of them. So looking at the subset of data we have to the left there, each column represents a specific material and each row represents a compound that we quantified. So we have benzene, toluene, ethylbenzene, and xylene sort of going from the top row to the bottom. Now focusing on that top row in the red box, which is benzene, we can see that the temperature or the different colors of the dots does change with, it does impact the amount of leaching that occurs. Additionally, there are differences that are observed between the different materials. Now, the PEC and the HDPE are relatively similar. However, those both vary significantly from the polypropylene and the PVC and CPVC materials. So the material does impact the leaching profile as well. So focusing more broadly on the VOCs and SVOCs that leached, we have a chromatogram on the right there, the top being an undamaged HDPE pipe and the bottom being one that was degraded at 400 degrees Celsius. Now, each one of those peaks represents a different compound that leached. The unburned materials, there was between 15 and 30 compounds that leached, depending on which material. These tended to be long chain hydrocarbons, and that number jumps up to between 70 and 150 compounds in the thermally degraded materials. And those tend to be those same hydrocarbons along with many aromatic compounds and ketones. If you're interested in learning more about this study, please visit the link provided. It is available to be downloaded for free. Additionally, if you have any questions, please don't hesitate to contact either Dr. Andrew Welton or myself. Our contact information is provided to the left there, or visit our website at plumbingsafety.org. Thank you.